we now move on to the next session by Shubhranshu on a very topical subject, of the Vande Bharat Express, a train that happened. So far, we were in the past. So now we are moving on to something that is occupying the minds of the Indians today. The moderator for the session is Ajay Singh. Ajay Singh is a rail enthusiast who was with the Indian Railways as a mechanical engineer for over 30 years. He has worked across the country with the Indian Railways in various roles, including a posting in the Ministry of Railways as a director. He has recently retired voluntarily from the Indian Railways to pursue his passion in the domain of water. He is an active photographer, naturalist, and writer. His photographs have featured in several publications, including a book cover. He is a life member of the Indian Steam Railway Society and one of the founder members of the Rail Enthusiast Society. Over to you, Ajay.
Thank you, Manoj sir. I have the honor of introducing Mr. Shubhranshu. Shubhranshu sir was an officer of the Indian Railways Services of Mechanical Engineers, spending over 42 long years with Indian Railways. His final assignment in Railways was as head of the rail wheel plant in Bihar, manufacturing cast steel wheels for railroad applications. In his earlier stints, he was the chief mechanical engineer at the Integral Coach Factory, heading the design and manufacturing team that made the first Vande Bharat, the iconic semi-high-speed train of India. He has also worked in policy roles at the Joint Secretary to Government of India level in the Ministry of Railways. He has vast experience in operations, design, development, manufacturing, rail safety, alternate fuels, technology transfer, etc., and has contributed to several key projects of Indian Railways. Diverting from the script, he has also been my guru as a faculty at the Indian Railways Institute of Mechanical and Electrical Engineering, IRMI Jamalpur, when I joined Indian Railways as a young apprentice in the year 1989. Over to you, Shubhranshu sir. Please share your presentation.
Thank you, Ajay, for the nice words. And good morning, good afternoon, everybody. Am I audible?
Yes, sir.
Yeah, you're audible.
Yes, sir.
So I was asked by the organizers to make a presentation on a train that happened. So I added a subheading to that. Let me start my presentation. So, what happened? Am I not?
Sir,
You did not share yet.
Please did not
Okay,
share.
I'll share my screen.
Shall I share from my end, sir?
No, I'm okay. Don't worry.
Okay.
Somehow it is.
Sir, share the first option, that is share
I
your
know.
screen. Yeah.
I'm trying to.
हाँ नहीं अभी अजय का okay.
Share the entire screen.
Okay. Yeah, excellent. हो गया sir.
Okay. So now this was the topic I was given. I added a subtopic called a dream that came true. Now you can see Apurva, you can see a train on the traverse, a coach on the traverser, as you mentioned. Now this dream was of a single man, a lone man, Mr. Sudhanshu Mani. You must have heard all of him All of you must have heard of him. He thought he would make a great world-class train. Not boxes that we've been making for decades. And ICF had made about 60,000 of them when Mr. Mani joined ICF. So all of us in his team are actually basking in his reflected glory. So ICF had all the skills, and they had all the energy to do this. Nobody thought of it, except when Mr. Mani came. He quickly built up a team and got a sanction from the railway board, approval from the railway board, and we got going. About a year and a half before the train was turned out, that was in mid of 2017, I was posted in Mumbai. He called me over to ICF. I wanted to come and see what we are planning to do. So I went there. He said, go to the design office and see what we are doing. I went to the design office. That was around June, July of 2017. And there was nothing there except a foreign railway photograph hanging on a wall of a train set. And from there, in 18 months, a full train was built. In February, he calls me, LC Trivedi is going away. Why don't you join him? Join in his place. So that's how I came to join the ICF and became a part of his team. So the ICF has been one of the temples of modern India as named by Mr. Jawaharlal Nehru, the Prime Minister of India. So I'll talk about the ICF very briefly and the train sets, why train sets, and what are the touch and feel items. What went into the design. You must have heard Mr. Mani's presentation several times on YouTube and all sorts of universities. It's slightly different, more technical, although I have removed the technical part largely because of Ajay Singh told me to make it more for common interest. So Indian Railways are a vertically integrated organization. They make their own rolling stock. They maintain their own rolling stock. They do their own design, validation, testing, and they even make their own components. So this kind of integration helped us induct a huge number of rolling stock and coaches and locomotives at a very low cost compared to the world prices. And that's how the poor country that India was in those days, and now it's still now a developing country, has been able to transport 27 million people every day. So as it was a temple of, as you can see, the world, I'm talking about the international prices, not the Indian prices. The annual rolling stock manufacture in India, railways and private, is $34 billion. This, I'm sure, is the largest of any other country in the world. As it was a temple of modern India, it was a must-visit stop for foreign dignitaries. So here is Queen Elizabeth, and here is Premier Chow En-lai from China. He writes in his Mandarin language. It's a modernized coach factory and all that. It's worthwhile for the Orientals to take pride in it. So when we started building Train 18, we started taking pride in it. You can see Mr. Bulganin and Mr. Khrushchev here in the ICF. That was the status of ICF in those days. It has made 600 types of coaches, different types, including military coaches. We have increased our speeds to 140 kmph. We made other train sets, more rudimentary train sets called EMUs, DEMUs, and so. But a breakthrough was waiting. That breakthrough happened to be the Train 18. So this is a book Mr. Mani wrote, which has lots of inside stories and anecdotes and the struggles that he made in the face of obstinate bureaucracy and sloth. And we managed to turn out this train in 18 months. The objectives were modest, 160 kmph, no 325 kmph, no world beating records. But the idea was to use the existing technology, Indian, and design and deliver in 18 months. Why 18 months? Because Mr. Mani was retiring in December 2018. So he wished that train had to be delivered before that. The axle load was 17 tons, which is the holy grail for high speed. In the month of August 2018, August 2018, we kind of panicked. Were we going to meet the December 18 deadline or not? So after the August 18, there were no Sundays, no holidays. On the 15th August, we hoisted the flag and went to the shop floor. That was the kind of work we did. No Saturdays, Sundays, no lunch at home, nothing. So that kind of work went into making this train. The design was more or less finalized. Design even was not complete. We were designing as we were building. So it was like, start moving, and then we will refine it. And nobody knew what was happening in ICF, although Railway Board had sanctioned it. So this was the first photograph that was leaked around August, September to people outside ICF. Even we were not knowing how great a thing we were doing. So once this kind of 1 or 2 photographs leaked, then people sat up and took notice. And what kind of a coach is this? And what is this black window all around? So we decided to make a continuous window. So that's how it looks like that. And then when this happens, then everybody took notice of this. And there were press meets and interviews and all that. The manufacturing paradigm that Indian Railways has seen, the shift from the post-independence, even pre-independence, was making a rolling stock out of steel plates and logs and rivets and bolts and make a locomotive or a coach. Today, the rolling stock is made on the best of breed philosophy. So was Train 18. Buy the best from the specialists, electrics, brake systems, whatever, and seek design help. We did take design help from others to refine our own designs. And it did help us big time. Just to speed up things, not that we could not have done it. We wanted to speed up things. And becoming a system integrator, and still you have to design, assemble, test, is the new paradigm that Indian Railway things have done. So we decided to select the best standards in the world, the best specifications in the world, which would make a train like this. We created a team of about 300 people out of 10,000, 9,000, 10,000. The best welders and the best fitters and the best in pneumatics, electrics would work on this project. So the train set was not new to Indian Railways. We already had EMUs, DMUs, MEMUs, but they were very rudimentary and they were not long distance. They were not high speed. They were 100 kmph and would go 150 kilometers. And they were not for long distance travel. They were not for the passenger comfort that you expect in a world-class train. The world was moving ahead. Japan, France, China, South Korea, Spain. We were nowhere. We are still not matching these, but our trains are as good as these. Our train, Vande Bharat Express today can do 200 kmph provided the tracks permit, with no design change. Now the loco haul train sets we have been having for decades, everybody in the world has. The main constraint was the loco axle load, 22 tons, which prevented high speeds, which was a restriction on bridges and curves, and the tractive effort was concentrated. So the per axle exploitation of tractive effort was only about 6 tons. So if you have 6 axle, you get 36 tons. Add some technology, you'll get about 45 tons, 50 tons. But if you have multiple axles, then you could do a lot more. So the Train 18 today has 13,000 horsepower. About 12,000 goes into traction. And there are 8 coaches which have a total of 32 axles, which are motored. The train set has a very unique advantage in Indian Railways systems because everywhere actually, the entire train set is built by one company as a single supply. Earlier, the locomotive builder was somebody else, the coach builder was somebody else. They had different design philosophies, different maintenance plans. One would be required to be taken to depot for after 15 days. The other fellow would want to go for after 30 days. So the idea was to build a train, full train, along with all its equipment, motor coaches, driving car, trailer coaches, which will be maintained as one unit, given scheduled maintenance or overall maintenance. And there will be no detaching one from the other and then connecting them together. The technology we wanted to own ourselves or through our vendors. So the idea was to have speed, comfort, noise. Noise is very, very little in this train. And the best thing was identical maintenance schedules, which we achieved. It is synonymous with high speed. We don't have high speed. We have only about medium high speed, 160 kmph. Mere horsepower is not enough. We need to have a distributed horsepower over the train. So that when you get better acceleration, better braking, because all the axles will brake in dynamic braking. So train 18 has a 2+2 format, a 4-coach unit, which has 2 coaches motored and 2 coaches unmotored, about 50% powering. High-speed trains in Japan and China have 100% powering. Every coach is powered. Now, multiple axles have a direct advantage. We knew this all along. As you can see, a loco hauled passenger service in the upper chart has an average speed of 39 kilometers per hour. Sorry. And a multiple axle train like a DMU or EMU has with same horsepower, same distance, same maximum speed, has a speed of about 55-60 kilometers per hour. So the advantages were obvious. You would like to have a train set. As you can see, even the braking distance is better. If you see the first one, the Rajdhani train, there's a braking distance of from 100 kmph, 571 meters, and train 18 has 392 meters. It was safer also. Acceleration was better, the braking was better. So we had all these train sets, DMU, diesel hydraulic multiple units, MEMU, EMU, metro coaches. So they're all train sets. We wanted a train set on broad gauge, which had technology limitations. We didn't have all the technology. We had, but not to those refinements. Most of the development in the world has taken place on standard gauge. Then we had limitations of tracks and bridges and signals and mixed traffic. So we aimed at semi-high speed, 200 kmph. We certified it for 180 and operationalized it at 160. The fare was expected to be high, which is high even now, but still being patronized 100%. Maintenance infrastructure had to be set up, and the Northern Railway in those days at Shakur Basti rose up to the occasion and set up a fantastic maintenance facility with people trained, spare parts arranged, and the Vande Bharats that we built were looked after very well by Northern Railway. So these are the major things: 160 kmph, axle load 17 tons, actually 16.5 we achieved. We were worried till the last day what axle load we are going to get. And we actually achieved within less than 17 tons. All high-speed trains in the world are 17 tons. We had a 4-car basic unit, so you could add multiples 4, 8, 12, 16, 20. So maximum we have done is 16, and the smaller ones we have 8 coach trains. So the TCMS, the train control management system, the operating system of the train, the windows of the train. This is where we had no expertise, India. So one of the lead vendors rose up to the occasion and built a TCMS from ground up. Millions of lines of codes, the hardware to match, and the networking to match. This has been, I believe, the single biggest factor in success of the train sets of the Vande Bharat Express. You can buy a traction motor from the market, you can buy a transformer from anywhere, but TCMS you cannot buy just like that. So this I believe, in my opinion, is one of the greatest achievement of ICF, that we got a TCMS which is truly world class. It controls everything: the braking, the traction, the automatic doors, the air conditioning, the passenger announcement, the onboard entertainment. It is the operating system like we have on the PC, the Windows 11. This is the operating system. The whole train is on Ethernet, and every coach, within the coach, is an Ethernet switch, and it transports the data from the Ethernet to doors and air conditioners through serial ports, RS485. So this is what the holy grail we achieved. The car body. Now this is where I joined in March 2018. So the first photo I took, the first coach was built and was being moved for painting. This is the driving trailer coach, the driver cab. And this is the continuous window and paint. Now, continuous window is not really continuous because there are pillars in between. So, but they're covered with the same glass. That is the window glass. So it looks like continuous. When you light up the coach from inside, you can see the brakes. And the paint. The paint that we use was from Exalta 3M, originally 3M company, which cost us 5 times as much as the ordinary coach paint. To a 6-layer paint, something what Mercedes would do on their cars. And a 7th coat was a nano coat water repellent, which stops water and dust from sticking to it. So 3 years later, when I went to Shakur Basti, the coaching depot where they were maintaining the train, I found them painting the coach. I said, "Why the hell are you painting it?" Sir, well, we won 3 years. 3 years is a painting schedule. I said, "This paint should last you 12 years. You are spoiling the whole thing by painting over this paint that we done so painstakingly." However, the paint scheme and the windows, where you can see the continuous window being assembled. This was the inside. You can see the pillars. One of the stages of manufacture. The flooring has been laid. The floor was a special sandwich, plywood and cork sandwich to reduce noise. The insulation, as you can see here, is a stick-on foam insulation, very much required for the Indian heat. Self-adhesive, which will last 15-20 years before it requires attention. This is one of the most expensive thing we bought. The automatic doors, they were so beautiful, we decided not to paint them. Let them retain their own color. Now this is the electronics and wiring required for an automatic door. We look at a door and say door is closed, door is opened. But this is what really takes one single door to open and close. You can see a spindle, horizontal spindle, which moves the door, and the controller circuit. This talks to the TCMS through an RS485 port. See the amount of wiring. It goes from coach to coach. Power cables, signal cables, communication cables. And the inside, more wiring is being done, lighting and air conditioning and mobile phone charging. So the idea was to start building. Do not wait for perfection. A product like this internationally is delivered in about 3.5 years. About 2 years for design and another year and a half for manufacture. We did the design for a few months, then started building, and lots of things came up in between, which we solved as we came. I'll come to that, one very good anecdotes. But we decided to select the best specifications and validations in the world. For example, the car body design validation, the stress analysis, was done to German standards, EN, all computer simulations, finite element. The bogies were also designed to some certain specifications. And when the simulation was done, computer simulation, dynamic simulation, it matched so closely with the actual results we achieved after testing. But we were also surprised that computer simulation can give such accurate results. Structure analysis for bogie frames. This is all some technical. Even nuts and bolts. We had standards for every single bolt. Critical bolt was to meet a certain standard. The wheel has to meet certain German standard. So we looked at how ready are we for the train and what are the shortfalls. For example, if you see the second item, fully suspended traction motors, they're required for high speed. We didn't have any design like this at all, except a few old electric locomotives. So we got a design consultancy from an international firm, and they designed it for us. The interior, if you see that last and second last, the toilets and the interiors was what would be the touch and feel by the passenger. And we spent a lot of time discussing with our vendors and suppliers and designers what kind of seats to get, what kind of toilets to make, what kind of color scheme to build. So there were some designs like jerks in LHB coaches, what to do. And we have not been able to solve this in several decades, LHB coaches, but in Vande Bharat we did. We found a semi-permanent coupler which solved this problem. However, this semi-permanent coupler cannot work on long trains. So it has to be a distributed power trains. It cannot haul 22 coaches behind it. So it's perfect for distributed power so that each coupler does not take all the load of the train. The double layer gangway, the vestibule, we could have built a similar narrow gangway, but this was done more for aesthetics than for aerodynamics because speeds are not so high. Then the plug door, the aerodynamic front for aesthetics as well as some reduction in drag. So as you can see here, the design started in April 2017 and we flagged off the first train from ICF for testing by RDSO in October, exactly 18 months. So these are the four, this is the basic unit, 4 unit. So there's a diesel trailing car, motor coach, trailer coach, and motor coach. So these 4 can be combined in as multiples, and we can make 8 or 12 or 16 coaches. This is some technicalities of how power flows from the overhead wire to the wheels. So these are the power ratings. This translates into 12,000 horsepower on the wheels. So we used proven world-class design systems, design software for design of the coaches and the layout and the bogies. SolidWorks, Siemens NX, Nastron Hypermesh, LS Dyna for fluid dynamics. I'll come to fluid dynamics a little later. And bogie dynamics tests. All of them are the best of breed. There is an interesting design of the air conditioning duct. By fluid mechanics, fluid dynamic analysis, we found that this is a simulation, it's not a real thing. So if there's a red, there's a noise. So you can see a red red breeze entering the coach, the passenger area, which means that area will be noisy. So a lot of iteration was done until we get all green. You can see the bottom one. So the air conditioning in Vande Bharat today is totally noiseless, unlike other coaches. So this is how finally the design, the air conditioning duct design ended up, designed by the computer. Then we had lighting like aircraft. For reading light here, you can see the circular lights and the diffuse light for comfort lighting. The flooring was very, very rugged and very, very pleasing. And we got the best of both worlds, a vacuum toilet and a biodigester. So the toilet commode is vacuum like in aircraft, but the waste doesn't go on the track or does not get collected. It goes into a digester, which is underslung from the coach. And a bacteria, anaerobic bacteria, works on it and which releases only clean water on the track. Does not cause corrosion, does not cause smell. Now it was decided that everything will be underslung, nothing will be on board, because we wanted all the space for passenger occupation. So this took a lot of design, because the designer would locate the equipment, then he would give it to the electrical fellow who would design the cable runs, how to make the cable pathways. Then he'll give it back to this fellow who will now design the cable trays. What happened in one of these designs, that we put a transformer here. If you can see, the transformer is one side of the coach. And we found that the coach is getting lopsided. No, its load is getting lopsided. It's not balanced laterally. So we had to weld a thick steel plate on the other side, about 200 kg. Just blank plate welded to the underframe to balance the sideways, the off center load of the transformer. And we were worried that this could increase the axle load, but it did not. We managed within 17 tons. That's how design kept evolving while we were making. Nobody thought that transformer would make it so lopsided. The bogie is simplicity itself. We have never had a simpler bogie in Indian Railways. And this fit for 200 kmph. So designed in consultation with an expert. You can see the wheel, the brakes on the discs. The same bogie is used for motor coaches. That simplifies things further. And in my heart, I had a suspicion that some of these bogies will crack in service. But 6 years and nothing has happened. Not a single bogie is cracked. The coupler, as I mentioned, was this Railner coupler, which gives a perfect design. It's now being used in push-pull Rajdhani also, between Mumbai and the same coupler. It has proven so successful that all distributed power will probably use it now. This is the coupler in reality. Semi-permanent. You can see the cables again. The project management of this was a real challenge. Everything something would clash with somebody. There were many vendors who would not talk to each other. For example, the TCMS fellow, the TCMS had to talk to the traction and to the brake system. They're from different companies. So I have to bring them together in a conference room and sometimes shout at one or the other and tell them to share the costs. This was one of the most difficult things to organize. How does everything, the doors, the brake system, the air conditioning, everything should talk to the TCMS, which was supplied by the propulsion supplier. This was happening behind Mr. Mani's back, of course. So the fine print. Our local vendors, the suppliers, really rose up to the task, and I must salute them, because I think all of them lost money in this project, hoping that they would make good later on. Unfortunately, the production stopped for 3 years. I hope they are being compensated now, because they did a lot of design work, transportation, logistics at their cost. We made special efforts in seats, flooring, windows, FRP, panels, couplers, propulsion, painting, interior paneling. So all these came from different suppliers, and all of them rose up to the task to work to perfection. The unprecedented cooperation between the vendors, the designers, the production staff, and the stores and finance departments, I have not seen it like this anywhere else. That credit goes to Mr. Mani's leadership. This was the meeting, this was the kind of meeting we used to have. No conference room meeting, no chai samosa. Everybody is standing on the shop floor, and there's a chart. You can't see the chart, it's hidden behind the crowd, of who is messed up, who has missed deadlines, and who has to speed up, and who is doing well. So these are all different suppliers. So they're all looking at each other and getting shamed or getting praised for doing a good job or a lazy job. And these meetings would last about half an hour, 20, 40 minutes. And we would disperse and go back to work. So this is how we held meetings on the shop floor. And then came the trials. The oscillation trial are done by RDSO. So there are 2 trials scheduled for every rolling stock, a low speed and a high speed. A low speed trial was for bad tracks to be done at 115 kmph, for operations at 105, and RDSO another trial at 180 kmph between Kota Savai Madhopur at 160 kmph. So for the 180 kmph, I decided to go to Kota from ICF. I'll tell you about that later. So there's an RFI trial, the radio frequency interference. When the train is passing through a suburb or through a village or through a town, there should be no radiation coming out of the train which will interfere with other equipment like hospitals, labs, residences. So the train should have radio frequency insulation from the surroundings. Then there was an EIG inspection, Electrical Inspector General inspection. This was a new factor, but we managed it somehow. Then the Commissioner Railway Safety. So the coaches had to be loaded and empty. So we had the full train to be tested. Normally RDSO doesn't do full train, it does only 1 coach or 1 locomotive. We had 16 coach trains. So fortunately, the four pairs had to be tested. The trailing coach, the motor coach, the driving coach, the executive class, loaded and unloaded, loaded and empty. So these cans that you see are filled with iron filings, iron powder. It's about 50 kg each, which is 1 passenger roughly. So each one of these was put under a seat to simulate passenger load. The pair of that coach was empty. And the RDSO did a very good job. They scraped the bottom of the barrel. They pulled out every single transducer that they had, accelerometer, and brought it to the trials. And the whole coach train was wired up like nothing else, nothing before. This is one of the setups. You see all these wires going out from the left side to sensors outside, inside. And here on the right hand side, you can see 180 kmph, which I was standing in the cab and took this photo. Now for the 180 kmph, they had scheduled a trial 3-4 days later. But when I reached Kota, the RDSO team was excited that the manufacturer himself is here. Let's do it. So I went to the cab, told the drivers, I'm here in the cab with you. If we die, we all die together. Don't worry. Let's do 180 kmph. And we did 180 kmph that time. After that, we had celebrations. These are the 2 loco pilots you can see on my left and right. And these are the laddus I had carried, hoping that we would succeed, and we did succeed. And here I am bribing the RDSO officer to pass the train, the first laddu. First laddu was given to the driver. Mr. Hamid Akhtar did an outstanding job. With RDSO, he was ED testing. Then a very funny objection came. What is this rooftop cable here? You can see on the left side, that orange tape cable. So people said, you can't have a bare cable running along the roof. So I said, this is how it is done. Because this is a bus bar, common bus bar, which connects the pantograph transformer of all the coaches to all other coaches. Fortunately, a team of railway officers were training in Japan. So I told them to go and take a photograph of the Shinkansen. So on the right hand side is the photograph of the Shinkansen. You can see a similar cable running along the train. When I showed them this, then they shut up. Okay, fine. So then they said, no, but your cable is bare cable. This is a shielded cable. I said, our cable is also shielded. Here it is in a pipe because it's a high-speed train. So fine, that problem was sorted out. There are a lot of things like this, people objecting. Then a fellow called Samir came into question. RDSO engineers told me that Samir has not agreed for an early test. What is Samir? I said, who is Samir? There's no who. Samir is a Society for Applied Microwave Electronics Engineering and Research. This is a central government body which does RFI tests. Samir had said, we will take 3 months to come and test your train. But the Prime Minister's inauguration was 10 days later. Fortunately, the Secretary of Ministry of Electronics and IT was my friend from Jamalpur. I told him, bhai, please get this done. We have to get it done, the Prime Minister's. So he got it done in 1 week. So Samir was tamed. And the inauguration. And the Prime Minister lovingly rechristened it the Vande Bharat Express. We had been calling it Train 18 till then because it was to be turned out in 2018. The first non-commercial run went trouble-free from New Delhi to Varanasi. I traveled in that 800 kilometers, but it failed. It immediately received a lot of acclaim from foreign media and newspapers and magazines. But it failed on its return journey. And our worst fears had come true. Did we miss something? What happened? How the hell this train failed? What happened? So a lot of adverse publicity came from media and opposition leaders and every Tom, Dick and Harry. Finally, it turned out that a battery charging cable had come loose, due to which the computer of that 4-coach unit had shut down. And before shutting down, the computer had applied brakes for safety. So a minor problem, we solved it. But lots of people, we were really worried that there could be other things which could go wrong. This is one thing. But I was, as a maker, as an actual shop floor man, I was worried that maybe something will happen in 10 days, 15 days, 1 month, 2 months, but nothing happened. It ran without a hitch for 500,000 kilometers. 1 full year. We were surprised. And it paid for itself in 2 years. Cost was recovered. Today, we have about 70 Vande Bharat trains crisscrossing all over the country. 78 more trains have been planned next 2 years. Plus 200 from private sector over next 5 years, 4 or 5 years. So the future is bright for Vande Bharat. You can see the new livery here, the orange and gray. So about 300 trains will come next 3, 4 years, 5 years. The new developments are many. The first sleeper train is ready, tested and proven. It is ready to be put into service. Now everything is indigenous, nearly. Private sector has been involved in a very big way. 200 train sets have been ordered on Titagarh and one on Kinnet. All sleeper coaches. So they'll go long distance, overnight journeys. Another 250 kmph train is being built by BML on standard gauge for the high-speed corridor that we're building between Ahmedabad and Mumbai. The basic design is the same as ICF's design. Vande Freight is a freight train, parcel train actually, not freight, small parcels train, which is being readied now for high-speed intercity parcel service. But while the train 18 was being built, ICF was doing lots of other things. 2018 was actually the most productive year of ICF. Many designs were being built, evolved and built in the background, and they were eclipsed by Train 18's propaganda glory. For example, this is the DEMU we exported to Sri Lanka. 6 trains, 10 coaches each. It was so popular that 3 more trains were ordered. And it became you can see on YouTube, it has become a kind of a folklore, these trains. The Japanese train drivers have refused to drive the Chinese trains. Sorry, the Sri Lankan train drivers have refused to drive Chinese trains, and we will drive only Indian trains. Very, very successful. This was the initial stages. You see the interiors of that same DMU Sri Lanka. We don't build like this for India. This is an air-conditioned EMU for Western Railway, 12-car, fully air-conditioned suburban train. This also went behind the back of train 18. This is single coach inspection car for railway officials for inspection of stations and tracks. This was designed and built in 8 months. It's now wildly popular among general managers and DRMs, and about 70 of these have been built by now. This is a MEMU, mainline electric EMUs, very similar to train 18 in the propulsion. The bogies and traction motors are the same. The coach car bodies are different because they're meant for mass transit. Now this was discontinued for some departmental disputes, but now it's being reborn as Vande Metro. That's all. Thank you very much. And I'm now ready for.
Thank you very much, sir, for your fast forward. Of course, all the efforts and those 18 months you must be recalling, under tremendous pressure of an absolute deadline, because there was no going back. I mean, going beyond December 18, as Mr. Mani was retiring in December 18, and that kind of set the tone for the whole development. But I must tell you, sir, all the efforts are all kind of paid off more than many times over, because the train has got so much love from everybody.
Yes.
I can personally vouch for it, sir, when the train was being inaugurated from Bangalore. I was in the train, and after the Prime Minister flagged it off, and throughout that platform and further when we travel, each and every station, people were just waiting and jostling amongst each other to take selfies with it. Not only that, sir, I can tell you, when I have foot plated, that is, I traveled for inspections in the locomotive cab of Vande Bharat between Dharwad to Bangalore. We had each and every station, people were taking selfies. Not only that, even in fields, in villages, people, when they knew that Vande Bharat is going to come, they will come along the track and have selfies. So that's the kind of love the train has got, and of course, everybody kind of acknowledges it. I have few questions in the chat box. I will take them one by one.
Yes, please.
Of course, lots of people have appreciated and accolades are there. One technical question by Mr. Manikandan is there. It's about the traction motor bogie. I mean, he appears to be knowing some separate anecdote on this development of traction motor bogie. Will you like to share that, sir?
Well, Srinivas was the chief design engineer.
Yes,
and he was the guy who actually designed the train. I was only his boss, and my boss was Mr. Mani. So I don't know what anecdote is referring to, but it was decided that both the bogies will be same, the trailer bogie and the traction motor bogie. For simplicity of maintenance, the brakes. So even, for example, the non-traction motor bogie could have had a disc on the axle, braking disc. But decided, no, we'll have the same braking disc on the wheels for similarity of wheels and brake systems. And of course, the traction motor bogie will have some additional brackets and mounting for the traction motors, but the primary design is same. So I don't know what anecdotes. I'll ask Srinivas.
Okay.
Sure, sir. Thank you.
Yes.
That was question by Mani. Perhaps he can share if he knows something interesting.
Yes.
Mani, would you like to drop in?
Srinivas is a genius. I mean, there is no match.
Okay. No, so I just happened to meet him when I through ICF.
Genius.
And he was telling me that it was pretty challenging, but he just took up the challenge and then he delivered it.
Yes.
Coolly. I mean, I think sometimes our talent is not appreciated as much, our homegrown talent. But really, this proves the fact that within ICF we had all the talent in the world, which was up to the world standard. So that's essentially what it was. That was what he was talking to me about.
Thank you.
Okay, thank you, Mani, for bringing this up. And we have Upamanyu Ghosh, who's asking, what is the technology behind the high acceleration of the train?
Okay, so this is a very fundamental question about traction. You see, if you have all the power in the locomotive, all the power can be converted into horizontal traction because of the friction of wheels on the rail on 6 axles. That's all. A locomotive has 6 axles. If you try to put a lot more power on the axles, the wheel will slip on the rail. But if you have a number of axles distributed over the whole train, that's why they call distributed power system. So there were 32 axles in the train which were motored. Four units of 2 motor coaches each. 8 coaches with 4 axles. So 32 axles, no axle will slip because they are well within the laws of physics. So if you want to have high acceleration, you must distribute the power over number of axles. Otherwise, even if you have high power, you can't exploit it. You can't convert it. You can convert it to high speed eventually after 20 minutes of run. But initial acceleration can be high only if you have a larger number of axles. There's no
And I can add
technology.
to this. In fact, this was the problem with steam locomotives.
Yes.
It was difficult
Yes.
to give power to every wheel separately. So you had coupling rods. You drove one locomotive and through rods you drove other wheels. So
Yes,
you had
quite
the
right.
two or three sort of wheels attached to each other. And that is one reason why the steam locomotive was always poor on starting. It could
Yes.
not compare to the present day diesels and electrics.
If you remember the first presentation on steam locos, you would have 2, 8, 4 wheel layouts. No? So eight wheels and 4 axles were
So coupled to each other.
powered. WP had 4 axles, WG had 3 axles. So it is the opposite. WP had 3 axles, WG had 4 axles for high traction.
Sir, the train ultimately evolved, or rather it was made into 2 different configuration, one 8-coach configuration and the 16-coach configuration.
Yes.
So how this happened? Probably when you were on the drawing board, you never thought it will be kind of split up and then used as a 8 train.
No, so I'll tell you what happened. I was sitting with the minister one day, much later after I was transferred out. I was in Bela. So he's saying, how many trains will be built? We have to build 50 trains. Prime Minister has promised this, that. I said, if you can, so you can build trains, build 8-coach trains. A train is a train with the 8-coach 16. So he said, okay, he caught on the idea. He said, let's build 8-coach trains. Now for 8-coach trains, you need to have 2 extra driving cabs. Because in 16-coach train, there are 1 driving cab at one end, the other at the other end. If you want to build 8-coach trains, you have to have 4 driving cabs for same configuration. So there were some changes done in the tender and purchase. But these 8-coach trains can be coupled together as a 16-coach train. The TCMS takes care of that. The TCMS has detection, auto detection, auto disconnection of trains. It knows that it has 8 coaches or 16 coaches. It has to drive 8, apply brakes in 16 or 8, or air conditioners, doors. So TCM is a very smart operating system. It permits longer or shorter trains. Of course, if you connect 2 8-coach trains, you can't have a through and through vestibule.
We have Aditya who's asking whether designers in different countries share knowledge. A very delicate question he's asking.
No, Aditya, they only share knowledge through journals or magazines, which is they're sharing their accomplishments, not knowledge. Knowledge is very, very secret.
Perhaps it's like that Abhimanyu, the last final thing they will not tell, how to get out of the Chakravyuh.
So there was nothing new, there's nothing technologically new in this train. It was bringing together different, technologies and integrating them. That's what it is.
We have Mr. Venkateshwaran Anand. Perhaps he has a question. He's raised his hand.
Shubhranshu, hats off to team T18.
Thank you, sir.
Starting with friend Sudhanshu Mani right down to
Yes,
people like, of course, Trivedi was there, then you, and then Dash and Srinivas.
yes,
So I can understand you manage the technology part very well. How
yes,
do you manage the unions? Because my experience in ICF was whenever there was a special job to be done, any export order or any, time-bound thing, they would come up with all kinds of unreasonable demands for overtime and such like. I think the biggest achievement was managing the unions.
So this answer can be given only offline.
Okay, okay.
Yes.
Sir, another aspect which
Yes.
gets talked about a lot is about the cost. It's almost, people talk in same breath, as we are very cost effective in putting satellites in orbit or sending this satellite to moon. Similarly, this train also costs quite less compared to the international prices. So what exactly were the, you can say cost points which helped you in keeping it down?
See, what has happened in the rolling stock business all over the world is that now the cost is driven by perception, like iPhone versus Android. I mean, both of them do a good job, equally good job, I would say. But an iPhone costs more. It should not cost more. A metro coach in India, even Delhi Metro and all these local metros, they used to cost 12 crores when they came. Now the prices come down 8, 9 crores. But we built a coach for 6 crores for Vande Bharat. With toilets, with better seating, with better air conditioning, better safety. But a metro coach comes for 10 crores because the iPhone of rolling stock. That's how it is. There's no reason why it should cost more. There's no reason.
May I
Perhaps
make a point? Sanjay Mukherjee here.
Sir,
I had raised this the cost aspects vis-a-vis traction, because
yes,
I remember that time we had very animated discussions regarding
sir.
diesel versus electric traction, and one aspect. The other aspect was imported versus the indigenous proposal of ICF, which was
Yes,
marvelous, no doubt
yes,
about it. And we batted very heavily against many odds
yes, sir.
the background to
Yes,
support ICF for this matter. Now that we've got electric traction also there in Vande Bharat and we're doing it indigenously,
yes.
in hindsight, what would be your thought? Was it a right decision at that time?
Okay, so I had a secret program running, unknown to Mr. Mani. Mr. Mani, I hope is in the audience today. Yes, he is. Of a train called Train 19, sorry, Train 19. A diesel train set with similar layout, internal, but driven by underslung diesel engines. This would be a 110, 120 kmph train, not 160, can't be 160 with diesel, but was primarily meant for exports. Because nobody would buy an electric train, no developing country would buy, they have no electrification. So in hindsight, for Indian use, sir, there's no doubt that this train is perfect. This kind of performance cannot be delivered on diesel. However, if we want to export, then we must have diesel. Yes.
Thank you, Sanjay sir,
Thank
for
you.
bringing in that perspective. We are almost 2 minutes only are left for our slot. JL sir, you would like to ask something
No,
before we hand over to
I
Manoj?
suggest we end now and we get ready for the next slot.
Okay, thank you very much, Shubhranshu sir. You had always been an inspiration for me personally and for the mechanical fraternity. It's wonderful to hear your talk and especially the background stories. Thanks for joining in for this edition of 5th Global RES conference.
Thank you, Ajay.
Thank you. Over to
I
you,
thank
JL
the
sir.
organizers for inviting me. Thank you so much.
Over to Manoj sir. Sir, I think we are almost in time for the
Okay.
next talk.
I can thank Shubhranshu as well as Ajay for a lovely session here, because people like me had no idea about what went behind the making of this wonderful train. And the question answers also showed that people were very interested to join in and clear their doubts about this train. Really, it has taken the country by storm.